Hey everyone, welcome. We're going to get started here in just a few minutes. We see folks starting to join in and add some little shout outs in the chat. Ads, good to see you, my friend. Glad to have you join us. Arishu, Shivam, Atul, welcome, welcome. Hey there, Lindsay. I love the emojis. Cowboy, yep. Harrison, welcome. Hey, Vince. Cool. We're going to give everyone a couple minutes, and then we're going to jump into some slides in today's discussion. As far as I understand, we are recording. So if we're not for some reason, then, well, whoops, but we should be. I have our individual from our technical marketing director in the background giving me the head nod. So, hopefully if you have to eat lunch, step away for a moment, your dog eats your YubiKey, you'll be able to come back and watch the section that you missed. So, hey, Christopher, welcome. Cornell, welcome.
Just hope
All
the
right.
YubiKey supports NFC, because then you can just carry your dog around to authenticate with you, and it's win-win.
Perfect. It's just bring your dog to work day. Anyway, here, I'm going to share slides here. We're going to kick things off. Give me just a moment. So we're going to go here to, there we are, webinar, boom. And then I will add that to the stream here. Cool. All right. Hey everybody, welcome. Really glad to see you here. So kicking things off today, I am Keith Hoodlet. I'm the Engineering Director for AI, Machine Learning, and Application Security Assurance here at Trail of Bits. Very excited to be welcoming some really great speakers today to join me on today's presentation. So we've got Vineet Sai, who's a security engineer, or senior security engineer, who's contributed to a number of OWASP projects, including the AI VSS. Really cool to have you here. Manish Bhatt, also very glad to have you here as well for some of the work you've done on Project Hyper and the enhanced tool definition interface that we're going to be discussing today. Also very glad to have Cliff Smith, a principal engineer here at Trail of Bits, working on my team. I hear that I'm getting a bit of an echo though, so I'm not sure if that's someone else's audio output. But okay, sounds like other people aren't getting an echo, so good. It may be just internal, so relieved. Anyway, we're going to jump right into things. So today's agenda, what are we talking about? Well, first, we wanted to make sure we're level setting on what is model context protocol. For those of you that are in a leadership role that maybe has less of like a formal understanding of the way that it works or operates, we want to make sure we just cover down on that so we all are on the same page. Then we're going to go into the MCP security implementations, which is, there really aren't any, but we're going to talk about some of those pitfalls of the S in security, or S in MCP stands for security. Then we're going to talk about the enhanced tool definition interface that Vineet and Manish have put together, as well as the MCP context protector released just yesterday by Trail of Bits and spearheaded by Cliff Smith here on the call. Then we've aggregated a number of questions from you all. So I've distilled that using AI to make sure that we answer as much of the breadth of those questions as possible, but we will have live questions available as well. So as you have questions throughout, please just go ahead and ask those questions in the chat. We will then flag those for Q&A. And then finally, we will have additional resources as well that we want to share at the very end so that people have a takeaway in the event that they want to learn more. So that being said, kicking things off with what is model context protocol? Vineet, help our listeners understand how does this work?
Yeah, hey Kit, thank you for having me. So far, when ChatGPT came out with OpenAI came with ChatGPT like a few years ago, everyone's mind blown, right? We all just did a lot of like chatbot, and like initially, none of these LLMs had like hands or legs or eyes, so they could see the real world. The only way to interface with them was via the chat interface. But Anthropic came out with this new protocol called Model Context Protocol. It basically gives LLMs a way to see and touch the world. Right? It's like imagine to be a USB hub where you can plug in APIs, tools, anything else that your LLM might need to interact with entities outside itself. Right? So that's at a high level what the context protocol is. So here in this architecture diagram, it's as you can see, right? So the MCP has three major parts. You have a host, you have the client, you have the MCP servers, and then you have the actual language model itself. The host application runs the client and also interacts with the LLM. And the client is one that talks to various MCP servers. You can have one to many servers, and each server can have one to many tools. So it's a like a many-to-many relationship out there. And most of you might have like heard about Cursor or Windsurf or any of these other MCP tools, like MCP hosts that also have like their own client, and talk to Cloud, which is the LLM model. So yeah, that at a high level is what MCP is. Just think about it as a way to talk, give your agents, so your LLM, also could be agents, a way to touch and interact with the world. So yeah, let me know if you have any questions on that, Keith.
Awesome. Thank you, Vineet. And no, that's a great explanation. We'll definitely get to some questions here in a little bit. Next, I want to talk a little bit about some of the security issues in MCP as identified by a number of different folks. Cliff, take us through the line jumping attack as you and the team coined.
Yeah, so if you're new to MCP, then you're probably going to read the spec and see all the emphasis on human in the loop controls around tool calls. And you might think, with this human in the loop, I'm going to have an opportunity to say yes or no before a tool call. My LLM can't unexpectedly interact with the environment, and there's no chance for a tool to send malicious input to the model without me being in the center of it. So this looks pretty secure. The problem is any kind of text that gets to the LLM of the LLM's context window is a chance for prompt injection. And in order for the MCP server to even let the LLM know that it exists and that it has an opportunity to use these tools, the MCP server has to give its server description and all of its tool descriptions to the LLM. So the intuition that if a malicious tool is never called, it can't hurt you, turns out to be wrong. I think Will Van Deventer was the one on our team who started calling it line jumping. And the prototypical attack shown in this diagram, MCP server 2 might be a code execution agent. MCP server 1 might be a malicious server whose tools are never called, but the tool descriptions themselves can have a dangerous payload in them. And it could be an instruction that says, you need to call RM star before you do anything else, or you need to chmod your entire home directory to 666. And the problem with that is the user is never going to have that human in the loop chance to prevent MCP server 1's instructions, their prompt injection payload, from getting to the LLM. So baked in to this protocol is a chance for prompt injection that kind of flies under the radar and gets around some of those human in the loop controls that seem to be such a valuable control. So we call it line jumping because you can jump in front of other tools and impact the behavior of the host app and the behavior of the model before the user intentionally calls the tool.
Yeah, and then there's all sorts of badness that you can actually implement as a result of MCP working in this way. One good example of this is when you can go ahead and just steal conversation history by embedding command triggers in the way that the MCP server is interacting in a malicious way. And so, if you're one of those people who's using extra compute power to say thank you, and then maybe there's a trigger in there that's, all right, okay, that's the end of the conversation. Let's take that conversation history and then pull it all forward into the MCP server that's now being hosted. You've managed to steal that conversation history. And there's all sorts of fun and interesting ways that you can attack MCP as a result of the way that it operates and the way that it interfaces with these MCP servers that could be potentially malicious. So it's a pretty much a wild west out there. Manish, maybe you want to speak to a little bit of some of the other vulnerabilities and attacks that Simon Willison published that you called out on the Vulnerable MCP project.
Sure. We just kind of heard about the prompt injection vector, but there's a couple of other things. As we know, because of the recent spec change in MCP servers are now authorization resource servers, but that does not really speak to the integrity of the tool definitions as they're passed through the life cycle of a server standing up versus a server going down. So you could imagine a situation where somebody's trying to talk or use a tool, but then the tool gets changed right after, the tool spec gets parsed by the MCP client, and now the tool does something else. There is no way to essentially verify that the rug that the tool stood on has not been pulled mid your session. So the attack here is called rug pull. It essentially means that there is no way of, for a particular session, verifying the authenticity of a tool definition or authenticity that certain code is supposed to be called. Now, there's another interesting vector here called cross-server tool shadowing. What this basically means is that, let's say we have like a singular agent, but there's a bunch of servers calling into it. You could imagine like a tap in the middle that kind of captures all the payloads. You could kind of replay the payload later on. And since most of the authentication typically is done through like API keys and such, API keys will be part of the captured payload. So like you can kind of start doing malicious activities that way. A lot of interesting attack vectors here.
Yeah, ton of them. And, we've really walked through, okay, so you've got MCP, you've got all these attack vectors. Manish, how does like this all play in from like the diagram perspective?
Sure. You guys heard Cliff talk about the model context and how it is a chance for prompt injection stuff, right? So if you look at the path between the host application and the MCP client, provided MCP server A and server B have malicious tool definitions with prompt injectable tokens in them, such as ignore previous instructions and do XYZ. We know that during discovery, the first tool spec is downloaded to the client, and then that spec might be parsed, and then you might hit the LLM again inside the application based on application logic. That provides an opportunity for prompt injection through tool spec definitions. That's where the context protector stuff plays in. The rug pull and the cross-domain tool shadowing pieces play in by because we cannot verify that MCP server A having tool A and MCP server B having tool B will consistently have this for the course of the session. So ETDI is more of a focus towards kind of cryptographically verifying the authenticity of the service in the first place. That's how the whole thing plays into the picture.
Awesome, thank you. And now, that being said, Manish and Vineeth, you've both worked on this enhanced tool definition interface that you've published out on your vulnerablemcp.info and the Vulnerable MCP project website. So just to make sure our listeners understand a little bit about the enhanced tool definition, or ETDI tool set, or process, I should say, what is ETDI and how does it operate at a high level?
ETDI is essentially an interface which automatically builds in protections such as OAuth scoping, such as cryptographically verifying the authenticity of the servers. It also does an additional thing called call stack verification. So like, let's say an MCP server has 3 tools, A, B, and C, but the user is only supposed to call tool A. It kind of prevents recursive calling. So sometimes you end up having like mistakes by the LLM where it's calling tool B instead of tool A. So ETDI also implements a protection to kind of block that by default. That way only intended call chains are allowed. There's a lot more to it. I'll let Vineeth kind of chime in for the rest.
Yeah, thank you, Manish. So Manish spoke about a few scenarios, right? Let's think about another scenario where you have 3 tools that have the exact same name. Like, all of us have downloaded apps that we've never deleted. So usually something similar, you like set up an MCP server and you keep on adding to it over time. Your environment might have multiple tool names for the same tool. Like a simple example is you have a calculator tool, another tool calculator, and like assume evil calculator, but it's just called calculator. How does your LLM know which calculator tool to use, right? So that's where ETDI comes in. So because we've modified the client itself, the MCP client itself, it prioritizes clients that have OAuth integration. So it makes sure you are able to authorize using OAuth, right? And what it does is it takes the OAuth token and does some cryptographic signing of the actual tool definition. So it's not possible for the tool definition to change at any point in the future. If the tool definition were to change, so like let's say it's a bad MCP server, they initially said, hey, this tool just adds the 2 values given, but actually they change it later after authorization to send us all your previous messages, and then we will add the 2 values given or something along those lines. This will trigger the client to break the OAuth, and you'll have to re-authenticate with the new tool definition. So this puts the onus onto the person using the MCP tool to validate that, hey, even if the tool definition changes, I am not inadvertently invoking these malicious tools. That's one thing that ETDI does. And the other thing that it really does well is scopes. So because we are able to define scopes for tools, so you can set this tool is only allowed when this scope is present and so on and so forth. So allowing for these finer grain access control. And we've also created a framework where you can go even more finer, like in terms of access control. We all know OAuth scopes are somewhat broad, but Amazon has something called CEDAR policies or OPA or any of these policy agents or policy tools where you can even finally define usage, tools, location, or any other like criteria you might have for when a tool can be accessed, can be integrated into the tool. So we created this high-level framework. The goal is to make this backwards compatible. So we didn't break anything when we released this. Everything here works with standard MCP. This is just an addition to make sure that we are not burdening developers and we also don't want to make security a roadblock. So we try to balance the backward compatibility as well as providing meaningful protection to users.
That's awesome.
If I forgot anything, Manish, please feel keep me honest here.
And just to check in with you also, so based on the cryptographic verification of tool definitions, for example, when you were writing this, like what vulnerabilities or attack categories really inspired you to build this in the way that you did, such that you were like solving for those problems?
The two that I initially wanted was like rug pull attack. That's the main one, where the tool definition changes after the initial setup. The second one is the like prompt injection via the tool definition itself. That I know Cliff spoke about and Manish also spoke about. And the final one is when you have multiple tools with the same name and you like tool poisoning or tool squatting attacks. Those were the main like inspiration for us.
Awesome. Awesome. And so then based on how you've described it, this is just sort of a high level of how this works, but maybe you just want to like talk through with the detail here on the slide so that people can understand that as you talk about OAuth flows, like where this all fits in this picture.
Yeah, Manish, feel free to jump in at any point if you like to. So at a high level, like I said, right, we wanted to be backwards compatible. So we just tweaked the client to add on the security checks we spoke about, right? So the client, most of the flow remains the same. The only difference is now that the client, which has ETDI OAuth enabled, we talk to the actual OAuth identity provider. It could be Okta, Auth0, any other OAuth identity provider. And we also made this framework extendable. So initially, when we launched the GitHub for ETDI, we just went with Auth0 and Okta, but you can always extend this. And because now we have the identity provider, which where the tools are also registered, so the client can verify if the user has the permissions to the tool that they're trying to invoke. Manish, is there something that I missed?
No, you covered everything. One only thing I would add is like you can also have like policy engine integration. That way you can have finer grained policies if you want. It's not like the primary feature of ETDI, but like it is also available if needed.
Awesome. Awesome. And then switching gears a little bit. So Cliff, yesterday, Trail of Bits published MCP Context Protector, a tool that you helped spearhead here at Trail of Bits, and then we published some content around it. Tell us, how does MCP Context Protector differ in terms of like the implementation, as well as maybe some of the problems that you were focusing on when we built and released this tool?
Yeah, so a lot of folks have been looking at this problem and have been blogging about it, have been releasing tools. The approach we used is we wanted to make the fewest number of assumptions about what would be going on in the ecosystem and what else would be changing in the implementation of the host apps. We wanted this to be universally compatible, simple, and as clean to implement as possible. And so we wrote this as a wrapper tool. So the easiest way, there's no guarantee going forward that Claude Code, Cursor, Windsurf, whatever, are all going to behave the same way and have the same sort of API. But fortunately, we have a protocol that lets us interact with virtually any MCP-enabled tool on the planet, and that's the MCP protocol itself. So the model is when your user sets up, installs a new tool, they just install it with this wrapper around it. That's the way that we chose to interact with the host app, emphasizing compatibility and ease of installation.
It's awesome. And then in terms of just like how this can be used, how does this fit in with like guardrails or quarantining or other things, according to what we've published and wrote about?
Yeah, so the ability to have a proxy sitting between the host app and the downstream server or tool gives you a lot of flexibility in terms of what sort of security controls you implement. And part of the idea is that teams will be able to take this tool, fork it, and implement their own security controls that meet their specific use case. It could be DLP, it could be searching for specific dangerous payloads, whatever. One of the main things that we did is somewhat like ETDI, we have trust on first use pinning. So once a user has installed and approved a tool, if there are any changes in the server instructions, the whole server is blocked until the user manually goes back in and tells Context Protector, this is safe and I want to use it. If a tool's description changes, or if a new tool is installed, that tool is blocked until the user goes in and marks it as approved. So it's another layer of human in the loop controls that makes it a little bit harder for the attacker to get that malicious prompt injection payload into the context window. One of the obvious shortcomings is there's a risk of alert fatigue over time, which is why we recommend that people follow the MCP specs recommendation and minimize the number of tools you're including in an individual server. If a user sees an update every 2 days, they're just going to go quickly into click, 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 approve, approve, approve mode. But to get to guardrails, as you were saying, Keith, we went ahead and implemented a demonstration of a quarantine, where if you want to use some kind of LLM guardrail framework, Llama, Firewall, Nemo, whatever, you can have your security wrapper, you can have Context Protector automatically scan every tool response. If there's one that looks malicious, then the wrapper can throw it into a quarantine, and when that happens, the LLM app will just get a generic message that says a tool response was blocked. Because in order for this whole security model to work, we have to prevent anything whatsoever from getting into that context window if we have reason to believe it's dangerous. That's how insidious prompt injection is, and that's how touchy of a threat model it is. Any text getting into the context window could be an exploit. So again, the user goes in, another manual approval, looks at the response, says it's okay, and then the LLM can release it itself through your MCP interface by calling a quarantine release tool that we add on there.
Nice. So it's almost like an extensible tool set where you can actually figure out, okay, not only you're going to put in MCP context protector, but maybe you're going to add some additional feature functionality to like harden this thing even further going forward. So incredible. Sounds really awesome. So next we're going to switch over to some of the Q&A. So we're going to start with the pre-provided questions. Again, the ones that are distilled from the many questions that we received from all of you who registered. So thank you again for that. So I wanted to start by asking, what are some of like the emerging attacks in MCP, Manish, Vineet, Cliff, that you're seeing out there today? I know that Trail of Bits, we've published a bunch, but Manish and Vineet, you've also put a bunch up on the Vulnerable MCP project.
Yeah, I can take this real quick and then let Manish go. So I think the biggest, like, I don't know if you guys have seen like the GitHub attack. A lot of these, like in the end, a lot of the issues are like not new security issues. Right? It's lack of input validation, a lack of proper authorization. So like the same security issues keep coming back to haunt us. It's just now the risk is much greater because you have a kid that has keys to a Lambo sitting in the driver's side with LLMs, right? They're inherently non-deterministic. So like maybe not related to MCP, but I don't know how many of you have seen like Replit delete an entire production database for a company during code freeze. And so like the impact of these can be much larger now that we are freely giving these tools access to our entire production database, so yes, the attacks that I'm most seeing still are in terms of prompt injection, injection via the tool definition, or like rug pull and so on. Go ahead, Manish.
Couple of like, as opposed to attacks, there's a couple of bugs that also come into mind. Those are like low-hanging fruits. There was an Asana one where like an MCP connector was able to kind of provide access to tenant data that wasn't like, let's say I had a tenant, but I was able to access somebody else's tenant data using the Asana bug. There was also another one for Anthropic's MCP inspector. There's been a few bugs where MCP is like the underlying I would say there's some design considerations that we want to make with MCP, and those design considerations end up becoming the root cause for these bugs.
Yeah, I know for us here at Trail of Bits as well, we copied some anti-terminal codes. So like basically things that showed up totally invisible to the user in the terminal, as like commands, as well as some credential storage behaviors that we've seen in MCP servers and published about as well. So I'll drop a couple of those blog links here. It's funny because you guys started answering the questions from the next one as well. So I want to make sure we drop some links here in the chat really quick. But Cliff, anything you want to add from an attacks perspective before we get into some of like the actual events that Vineeth and Manish have already started to talk about or discuss?
There is one I want to point a finger to. Of all of the features in the protocol that we've talked about and we're slowly beating to death, bleeding this horse to death in the blogosphere, the one that is getting a lot less attention than it probably deserves is sampling. And the reason why sampling is interesting from the attacker's perspective, almost on a philosophical level, it's a way for the MCP server to actually request an LLM completion from the client. So it's a way to kind of turn some of those arrows around backwards and make the client act like a server and the server act like a client in a certain way. So if there's any part of the spec that I think is going to become more interesting as more and more apps add support for it, it's definitely sampling.
Nice. So I know we've already started to discuss some of this as well in terms of real world incidents that have happened. So there was the recent one that I think, Cliff, that you brought up to me just this morning before we got started on the MCP remote vulnerability. Do you want to talk to that a little bit?
Sure. And that was an example of I haven't done a full in-depth audit of the code, but it was a remote code execution vulnerability in the OAuth layer. Now, I realize I'm playing Monday morning quarterback here, but OAuth is one of the very last parts of an MCP server that I would want to implement from scratch. There's so many libraries out there that are very carefully written, very well tested. It turns out that's where the bug was. One of the URLs was being opened with a call to a generic open function in a library that made no distinction between an HTTPS URL and a file on your local file system. So if it's, bash taxi rm star, well, guess what? You've got a problem. And it's interesting also because that is one of the underemphasized elements of the attack surface. I think malicious OAuth traffic from a malicious server is one of the last things people think about when they're building this kind of software stack. So it goes to show that every time you interact with someone who is not you, there's a potential for malicious input to show up.
You mean the internet is dangerous? Anyway, so Vineeth, I know earlier you mentioned, it might have been yourself or Manish, mentioned the Asana attack as well. I just dropped the Nudge Security blog on this, but do you want to maybe speak to that a little bit?
Yeah, it was me. So Asana had like a feature that essentially provided an MCP API interface to access tenant data in the backend. But because there wasn't like strong isolation cryptographic guarantees, there was tenant data leakage. So you could essentially access data that didn't belong to you, but belonged to any of the other Asana tenants, which is kind of a low-hanging fruit in terms of information disclosure, but it is kind of a big one in terms of like corporate information disclosure.
Oof, yeah, sounds like it. Then there was, of course, the GitHub one as well, which Simon Wilson covered around the GitHub MCP. I'm not sure if any of you want to speak to that as well, but I'll drop the link here in the chat. All right, no takers. It's okay. We got more questions, so we'll keep them coming. So in terms of like practical steps, what can security teams do to operationalize MCP security controls? Like we've talked about ETDI, we've talked about Context Protector. What advice would you give to security professionals thinking, okay, my business wants to launch 1,000 MCP servers. How do you secure these things? How do you implement processes or implement tooling to make these things safe?
I can start, maybe. Okay. I think one key thing to think about is how do you like bootstrap the trust in terms of the servers, and how do you ensure throughout the lifecycle the servers are who they say they are from like a remote client perspective, right? Because that requires like strong authentication. That also requires like delegated authentication, where like you as a user start an agent, the agent makes a tool call, but there's some kind of delegation in terms of identity management. So yeah, like it's the core crux is about maintaining trust between the code you ship as an MCP developer, as well as like ensuring there's strong authentication guarantees there.
I would suggest that we should view this partly as a corporate IT problem, and that's probably the most exciting 2 words that you can think of in the English language. But by that I mean, think of how many years it's been such that a mature IT department will know within 5 minutes if someone installs a file sharing app or a BitTorrent client or who knows what on their laptop. Y'all are going to know about that very quickly. And we need to have the same focus and visibility on MCP servers. So the Claude desktop config, all of the config files for every one of your desktop LLM apps that support MCP needs to be a first-class priority for your IT department. And if you're going to enforce use of ETDI or MCP Context Protector, any of the other security tools that are out there, the IT staff needs to keep that in mind. And we'll talk about this a bit more when we talk about some of the papers, but understanding your own threat model is absolutely critical. So contextualizing all this decision-making against the backdrop of what your staff are doing with LLMs. Is there proprietary code in there? Is there PII in there? Is there, heaven forbid, PHI in there? Other regulated financial or healthcare information? So make all those decisions, design and enforce your controls based on what your organization's risk is.
Yeah, for me, it's always, I come back to process, right? It's one of those things where you have to make it really, really easy for not only like self-identification of the fact that these things are being spun up within your ecosystem, but basically opening the door and having a big set of neon signs that just says like, if you want to do this, please reach out to us so that we can make sure you have all of the proper guidance on your hopefully not backdoored and shelled SharePoint instance, in which you can go get that information from your security organization. Because if you keep it in a silo, it's never going to get used. But if you have it readily available and accessible, hopefully that means many people within your organization will start to make use of that. On to the next question, though. So what's missing from defensive tools and the MCP limitations? Like of the things that have been implemented so far, what do you all feel like is maybe the next step on this journey? Or maybe someone can make like a PR into some of the repos that we've shared to like enhance the ETDI or MCP context protector tool sets.
There are probably additional ways that a tool like MCP Context Protector should have hooks or interaction points. It's quite possible that as people start using these wrapper tools, come up with new ways that they want to use this direct access, this ability to get between the context window and the remote MCP servers, that they'll need a new framework for which to manage those interactions and easier ways to develop the kinds of security controls you want quickly. And so in keeping with trying to be unopinionated about how it's used and emphasizing compatibility, it's likely that we'll need to, if this takes off, we'll need to add some new interaction points, and we certainly welcome that.
And I know Vineeth and Manish as well, you both really encouraged adoption of ETDI as a formal set of functionality within Anthropic's MCP code base. Maybe you want to speak to that a little bit. I know it sounds like we've got some folks here maybe from Anthropic on the call or on the webinar.
Yeah, so we didn't want security to be an afterthought, right? The goal is to shift as left as possible and make the default the path of least resistance a secure path. And so instead of like our thought process was, hey, if we can bake these into the protocol itself, now it becomes standard and we don't have to worry about, oh, did I do this or did I not do that? I thought would be the easiest way to move forward. Secure by default is how I'd like to operate. And that's why we built, even though like there are some known issues with our implementation, right? So like what happens if the tool says it does X, but the actual API calls do Y? We don't have like those issues, still persist even right now, but we could have fixed those, but they wouldn't have been backwards compatible. So we had to make trade-offs between how much security we can push in versus how difficult it'll be to implement, and having the right balance, especially that I work quite a bit with developers. Security is already seen as, security, I have to deal with them. I would rather prefer it to be, security, it's taken care of, I don't have to worry. That's what my thought process there.
Yeah, it makes a ton of sense. Manish, anything you'd like to add here?
One thing I would add for ETDI is I would encourage the community to kind of go to the repo and kind of make issues in terms of if something is missing that they think that should exist. So for things like that, right now it's an MVP that works with Auth0 and common OAuth providers. Maybe folks want more of OAuth providers. We don't know yet. So we would encourage folks to kind of go in and look into that stuff too.
You mean you want people to contribute to an open source project? Wow. Cliff, I think you're in the same boat with MCP Context Protector as well. I remember in discussions on how we launched this, that we really did want it to be something that people felt they could contribute to. Anything additional you want to add there?
I mean, I think this relates to a question I see in the chat about Camel, where Context Protector is meant to be a tool that is easy to get up and running with. So Camel, to kind of, for those who might not have read the paper, might not remember, it is a much larger framework, a bigger approach to securing agentic AI, where an actual planned out series of actions is compiled into Python-like pseudocode and then analyzed with an AST, basically a static analyzer, to check data flow restrictions. So if you are able to implement that, that is the end game. That is one of the best approaches we know of to securing agentic AI. And as an aside, I'm going to shout out one of my colleagues, Suha Hussain, who's about to be publishing some very important research on multi-agent system hijacking. So that's right at the horizon. But I would say keep in mind that a tool like Context Protector is meant to be quickly implemented. If you have the time to do a full threat model, to understand and model your agentic AI systems in a way that you can narrowly constrain what they should be doing. This type of data should go here, but not there. This tool should call this one, but not that one, and so on. Then fully embrace that and stay away from relying on the solutions that are emphasized for ease of use, like Context Protector. Anytime you have a solution that is tailored to your organization's use case, and you have the resources to put the attention and effort into it that it deserves, that's always going to get you the best result.
Love it. All right, so we're going to move to live Q&A now. I've been saving a bunch of questions that you all put into the chat, so we're going to try and do these rapid fire. We've got 15 questions saved up. So I'm going to try and go through them in the order that they were saved, and hopefully we'll hit upon all those points that you folks have been asking about. The first one comes from Alex. Will rug pull attacks work in IDEs like Cursor or Claude Desktop? And are these IDEs vulnerable to rug pull via MCP? I'm not sure if Manish, Vineeth, Cliff, any of you have any comments here.
I mean, yeah, I mean, I don't see why not, right? If the tool because IDEs like Cursor and stuff it's not in their purview to see what MCP tools that you're installing, right? You can install any tool you want, and the server for the tool that has the definitions for the tool, they can always change what the tool definition is, and there's no way for Cursor to know if it's a good change or a bad change. So I don't see why this is not something that can be done. But I mean, we are getting more aware, so we're not randomly installing MCP servers from the internet. So it's less prevalent. But if for some reason you install an MCP server and it's supposedly not the official one, because a lot of times people say, oh, this is the official like Salesforce MCP server, but it's just some dudes, GitHub. It's possible that these attacks can still come in. I don't see why not.
And to be as concrete as possible, the exact threat depends on which transport you're using. If you're using the STDIO transport and the code is running on your local workstation or server, wherever it might be, the risk is that a software update makes a server that was trusted as of installation become dangerous or malicious. In the case of HTTP or Streamable HTTP or SSE, that code is running on the cloud, aka someone else's computer. So the risks are myriad. It could be that someone pushes malicious code into their repo, whatever's running the code that runs your MCP server. It could be that somehow the transport layer gets hijacked. It could be that someone gets a machine in the middle attack and actually intercepts the traffic or something like that. So there are two very different ways that a previously trusted server can become malicious. But I totally agree. All Claude Desktop does is run the command you tell it to run. It can't verify that the software hasn't changed between two invocations.
So there's also an additional attack vector here, right? Let's say you expose arbitrary MCP services on your IDE. But then your IDE also has tunneling capabilities like VS Code tunnel or any of the other tunnels that are used for dev purposes, right? So that way you can expose the MCP server that was supposed to be exposed locally across a tunnel network now. And if your MCP server has capabilities to runtime, like drop files and swap, so you can do runtime modification of set extensions and modify MCP servers that way. So there are definitely avenues to pull off RUPL attacks on the fly on an IDE.
Yikes. All right. So it sounds like, be careful when you vibe code is what I'm hearing. All right, let's move on to the next one. So the key question is like, this attack only really works if the malicious MCP server is already installed. I think short answer is yes. Like you sort of have to install an MCP server that is malicious, or maybe you've installed one that is useful, and then like there was an account takeover, or they've sold the project, or someone else is now like a maintainer that has been like earned the trust. Like it was a Jian Tang. I'm trying to remember the actual handle, but like, earned the trust of the maintainer. There's no way, as far as I can tell, that you can actually like put yourself in line in a way that makes yourself like a malicious MCP server that wasn't installed. Just to confirm with yourself, Manish, Vineeth, and Cliff, am I wrong about that? But to me, this feels like a pretty straightforward. You got to install the thing first. Yeah, seeing some thumbs up.
Yeah, you got to install the thing first, but you can chain it with other avenues to do a runtime patching thing. Using like tunnels, for example, if you're able to talk back to the MCP server and write stuff to the file system, you can override existing extensions, and you can do stuff like that. But yeah, like it requires extra steps. It must be installed in the first place.
Yeah, so basically it's just don't trust, random project on GitHub when you install an MCP server. Maybe do some diligence first. All right. So there was a quick question that just asked, are there any demos in the current session? Unfortunately not. We are getting used to this new webinar platform, and so we didn't have a chance to like ensure that demos would work. And we also didn't want to like suffer the wrath of the demo gods, as we've all experienced at one point in our career or another. So there are lots of examples, lots of screenshots, lots of material, both in the ETDI vulnerablemcp.info page, as well as within Context Protector and the blogs from Trail of Bits. Always, of course, reach out to any of us here as well if you want to see or discuss more. This next one, though, I believe is ETDI specific, which is regarding signing. Are we simply talking like a hash of the tool when it comes to ETDI and the way that you're like ensuring that the thing is properly validated?
Yeah, I can take this, and then Manish, you can. Yeah, so what we did is when we initially did the OAuth verification, right? So you set up your OAuth flow, you get the OAuth token. We basically used at a high level, we used that OAuth token as the base from which we hash like cryptographically like store the hash, like basically hash the tool definition. And if at any subsequent time, if the tool definition changes, the hashes don't match, it'll reject. But Manish, do you want to talk about the exact thing that we did there?
That's pretty much it. There's also this added thing where you can have certificates and you can actually do signing, so that like whatever tool definition exists on the server side is signed and the signature can be verified. But yeah, I think you pretty much covered.
Yep.
Cool. I'm going to jump actually to another question related to ETDI. So does tool authentication part with OAuth act as a token broker through token exchange? I see Manish is shaking his head no.
I don't know. I don't know what token exchange is. Is it a library or is it like a platform? I'm gonna venture on the side saying no.
Okay.
It is entirely based on OAuth primitives, like from the fundamentals.
Okay. I'm going to jump to this next one as well, because there's a lot of ETDI discussions here. Can we use it with IDEs? I mean, we talked about earlier how like the IDE just sort of like blindly trusts the tool. Is this possible? Because again, people want to use Windsurf, Klein, Cursor, you name it.
So I answered this in chat, but I'll explain this again. So the goal was to bake this into the protocol itself and into the clients itself. The problem is most of the IDEs come in with their own baked in MCP clients. We don't know if they're using the actual like the open source public MCP client or some customized version of it, but it the IDE needs to have the client installed. If there are some IDEs that allow you to swap out the MCP client, you should be able to do it. But for non-IDE based work, if you're using standard, like you're running an MCP server client on your terminal, you can just use ETDI as is. But yeah, that's where the working with the open source community becomes a challenging part when you're trying to merge stuff into really large protocols that are being used by a lot of people.
And making sure that you're accepting things that you actually trust in your vetting as well. Again, Jian Tang notwithstanding. So I
Yeah.
totally hear you there.
Yeah.
The next one's actually a context or MCP context protector specific question. So it's about the wrapper model. How extensible is the wrapper, and can custom guardrails processes be defined for MCP context protector?
Yeah, and that's a good question. Right now, what the guardrail provider framework we have in there is centered on scanning tool responses, because that's one of the ways, aside from a server instructions string or a tool description, that's one of the easiest ways for a malicious server to get a prompt injection payload into the context window. So it's an opportunity to scan a response for something that looks like prompt injection or otherwise a dangerous payload. So it's as people use this tool and find other ways that they want to take advantage of this wrapper architecture, there may be additional plugin points that we build so that you can interact with the process in a different way and give the wrapper a different kind of opportunity to say, yes, this is okay, no, that's not okay, and we need to either ban it outright or make the user manually approve it.
Got it. Got it. Next one's an ETDI question. So thank you, Maya, for the comment around it being super interesting. The question is really around SPIFFE and SPIRE for cryptographic verifiable workload identities. And what is the connection relationship between SPIFFE, or I hope I'm pronouncing that correctly, and ETDI?
Yeah, I can take this. So at a high level, like Manish said, we use full OAuth primitives to just like sign the actual the tool definition. We didn't like, but this is extendable to use certificates or any other identity system you like to use. But as for like, I did see SPIFFE and Spire. We didn't go that far ahead in terms of like distributed ways to do authentication, because we didn't want to get into it becomes a Pandora's box once you open this. There's so many different ways to go about with this. We want to make the minimum viable secure product here. So the only place where we did the cryptographic verifiable workloads is just on using the OAuth token as a base for hashing the tool interface definition, nothing else. And in terms of the actual auth, everything is handled by OAuth, and we didn't really venture out into the auth world. I know people have really strong opinions in the auth world, so we wanted to minimize the tab versus space, debates with auth here.
People are specific about auth? Jeez. Harsh. I joke. So we had another one for ETDI as well. So how is the ETDI going to interact with the finer grained access controls on the MCP specification roadmap?
So no, we don't have an answer, because again, this didn't get. It's still an open PR on the protocol. I don't know if it'll get accepted. That's why we have context protector, which is the other flip side of the coin, where even if it doesn't work in the protocol, you can always add it as a add-on. So good question. Yeah, we don't have an answer because it hasn't really been integrated yet. Hopefully one day.
Yeah, it's always like the open PR. You just wait for it eventually to merge and hope that it will. So I hear you there. We did have another one here for context protector. So let me just grab it really fast. No, I just had it. Now I've lost it here. Let me come to another one. So this is a very high level one, and I think this is good for maybe each of you to discuss. But what is the recommended way to deploy MCPs today onto servers? Like, what's the right way to do this?
What's the right
Let me
way
say
to?
securely. Go ahead, Manish.
Well, first, being intentional about what we're building is the first thing. The second thing I would say is having strong, like at least at the binary level, signature level verification to ascertain that the code that was committed is the code that was shipped, right? That kind of takes care of some of it. And then there's also like, so any input going into the model has a chance for prompt injection. That's where stuff like context protector kind of chimes in. So using as many guardrails for your needs as possible, but like for your needs, you don't want to kind of take every single guardrail in the world and just jam it in front of MCP and hope for the best. We want to be intentional about what we want to do in terms of securing MCP. And authentication is a big one. Like we really want MCP servers to be authenticated somehow, and we don't want open MCP servers to be available on the internet. So those are the top of mind things for me.
Vineeth or Cliff, anything you want to add?
I mean, I think Darren's question in the chat, have you seen any good corporate policies that strike the right mix between allowing experimentation with AI tooling and the emerging risks? Asking for a friend. I think that question dovetails into this one nicely. For example, at Trail of Bits, we all, the security engineers, know pretty clearly what we're allowed to do with what. We know how we're allowed to handle internal only code on the tools we work on. We know how we're allowed to handle client code. So the expectations for that are very, very clear. And, you know, we don't have a whole lot of guidance around MCP because we spend our days looking and thinking about this stuff. So I think if we were to have, with the user base who are not security engineers, I think everyone has gotten an appropriate level of fear around this stuff. But I would say one of the biggest pieces of advice I can give is to bear in mind that of all the registries that are out there, all the places where you can say, hey, here's a place where you can discover 1,000 different great useful MCP tools. These are registries that have no standard for how they review what gets in there. There's not even a convention emerging for what responsibility those registries take on for making sure these tools are safe. So take on that risk exactly the way you would the risk of any other open source software. But just keep in mind, this is probably a piece of software that's going to touch some of your most sensitive data. People say, you know, I'm going to say Sam Altman the other day pointed out the obvious, that conversations with ChatGPT do not have legal privilege. Even if you're asking for legal advice from an LLM, who to thunk it, right? So bear in mind the high sensitivity of the data that people are going to type into an LLM if you don't explicitly tell them that they can't.
Yeah, that's a really good point. In fact, one of the other questions as well, to your point, Manish, was this one around camel and FIDEs or FIDs. And in my mind, there's a lot of different ways you can do this. I mean, camel is just one implementation among several that we actually link to for some papers here in the resources section at the end. And in my mind, it's to your points, Cliff, being intentional about the way that you've designed the system and understanding what potential inputs may be used and what sort of data may be received back and who controls that data. I mean, if it's just documentation that is internally controlled by members of your employee group, that's probably safe to interpret back and pull data from that as long as it's segmented and properly authenticated and things of that nature. But when it comes to Camel and other implementations from a design perspective, it's really thinking about, in my mind, from a web attacker perspective, I think of like second order SQL injection, right? It's like, maybe I'm not getting SQL injection on the first one, but I'm getting it because it's stored in the database and the system that's reading or parsing that data is now getting hit with the SQL injection instead. It's sort of similar when you're designing an MCP implementation where you're thinking, not only what does it have access to, but also what actions can it perform, and who controls the data that it's reading from, as well as who controls the data that's writing into it in some fashion, and then what can it do with that data. These are all just like design problems, and I've seen even folks like Daniel Miessler just within the last week or so go out on LinkedIn and say, like, what we need is for engineers to all get really, really good at designing and architecting right now, because like the writing of the code part is going to become a lot easier, but the designing and then the proper implementation part is about to become a lot more challenging for folks. I want to come to maybe one more question before we just get toward the end here, but I did want to bring up this one for the ETDI section, which is, do we have recommended path for companies who are opening up to using MCP servers everywhere? Like, how do we get them to do things like that ETDI asks for? In my opinion, I think the first thing is publicizing the fact that you are, following and providing guidance and linking people to resources, and becoming a very like visible and vocal expert in this space within your business is probably the first place that you have to start, which is like you have to let people know you exist, and you have to let people know that there are solutions to the problems that they are about to face, and then give them actual examples of those real problems. Like don't hit them with fear, uncertainty, and doubt, but just sort of say like, did you see this thing from GitHub? Did you see this thing from Asana? Did you see this thing from, and so on, and just say like, these are real issues that we're trying to solve. And oh, by the way, did you see that webinar with Manish and Manish and Vineet and Cliff and Keith at Trail of Bits, over this topic, right? Like share resources, make it really public. But I don't know, Vineet, Manish, Cliff, is there anything you want to add here?
Yeah, I just want to say like installing an MCP server is no different than installing an Nginx server. Like really, if you're opening it to the world, if you're doing like the core security principles that we've known don't change. You're just adding, there is some additional delta that comes with LLMs, but realistically, like container security, having like, strong source code control, like Cliff said, like, when, if you install a torrent, emulator or like a config on your work laptop, security will be on your door tomorrow, right? Or even maybe tonight. So like those should not change. You should still treat this as how you would treat any other client side service if you're doing a client MCP client or server, things like that. So make sure to like always remember what you all like have been doing for the past few decades. But going forward, just like Cliff said, architecting in a secure way and following best practices. I know like with AI we want to move fast and break things, but moving fast and breaking things in a safe and secure container so you're not impacting your money making production sides to so that's really the one thing I really want to like emphasize, that nothing here today that we spoke is really like groundbreakingly new. It is just the implementation and like changing the mindset a little is what that's new.
Yeah, welcome to the year 2000 again, where all the vulnerabilities are just like wide open application servers that don't have proper authentication or segmentation or things of that nature. That said, I know we're getting close to time here, so I did want to just very quickly say congratulations to our winners for, here, let me just turn off the Q&A here for a moment. How do I turn this off? New system, folks. Thank you for whoever clicked the button. Just want to say congratulations to our winners who are going to grab lunch with Cliff and myself out at B-Sides Las Vegas coming up just next week. So if you're going to be out in Vegas for B-Sides Las Vegas, Black Hat, or DEF CON, please just reach out to us. I'm Keith at trailofbits.com. Would be happy to connect with you in person. And Cliff and myself and other members of our AI/ML security team will all be out there. Unfortunately, Vineet and Manish will not be able to join us due to job responsibilities that they have. But next year, we look forward to seeing them and hopefully having another roundtable with them. Finally, just wanted to drop some resources on all of you for like things you can go and look at and read. We've got the Trail of Bits blog. We've got Context Protector, and I should update that to say MCP Context Protector. My bad. The link is correct. The tag is wrong. But then also the vulnerable MCP project from Vineet and Manish, as well as ETDI. And then there's that design patterns paper that goes into several different ways that you can actually begin to implement secure capabilities or secure design patterns within the ways that you're using AI at your businesses today, inclusive of some of the features from the Camel paper dropped by Google. That said, thank you everyone for joining us. I really appreciate you spending some time with us today. Hope you have a great rest of your week. And if you're going to be out in Vegas, we look forward to seeing you out there. In the meantime, remember to git commit all of that code before your AI deletes it on your behalf, and stay classy. Cheers, everyone.
Thank you, Keith. Thank you, team. Bye bye.